Hello, our project is Lost and Found web system for Chiang Mai University. Let's dive into the background. At Chiang Mai University, lost items are currently handled through scattered Facebook groups, help desk, and social media. This makes it difficult to verify your owner, increases the risk of fraudulent claim, and creates language barrier. For people who find items, they often don't know how to locate the owner, so they post online or give items to staff. For those who lost items, there's no centralized place to search, so they must check multiple locations, which is inefficient. Our goal is to build a centralized platform for managing lost and found items at CMU. The system helps admin record and verify items, reduce fraud using AI-assisted claim verification, support both Thai and English users, and allow easy online searching and claiming with digital record tracking. We work under several constraints. We have a limited budget, so we use lightweight tools like Cloud Haiku and Railway. We design bilingual system for both Thai and international users. To ensure sustainability and easy development, we use modular architecture with Docker. We also optimize the system to reduce server resource usage. For the benefits, this system reduces staff workload and prevents replacement costs. It eliminates paper records and reduces unnecessary travel. Most importantly, it improves finance by reducing fraudulent claims and making the system accessible to all students. For our workflow, a finder submits an item to the help desk, and the admin records it in the system. Owner searches for the item and submit a claim online. The system uses AI to evaluate the claim and assist the admin. If verified, the item is returned to the rightful owner.
Next, I will explain the system architecture of our platform. Our website uses a client-server architecture. The front end is built with React, which handles the user interface and allows users to interact with the system through the website. The back end is built using Node, which manages an application logic such as processing item claim and communicating with database. All data is stored in a PostgreSQL database. The front end and back end communicate using a RESTful API. For example, GET requests are used to view items, POST requests are used to submit claim, and PUT or DELETE requests are used for admin management. To ensure the system is secure and reliable, we implement thorough security and database engineering practice. For education, we use CMU Entra ID, allowing students to log in using their university account. For our database, follow a third normal form structure, which reduce redundancy and improve data integrity. The main table includes user, item, and claim, connected with foreign key relationship. One of the key features of our system is AI-assisted claim verification. When the student submit a claim for an item, the system prepares a form containing the item detail, the claim description, and CMU contact information. This information is sent to the Cloud API for analysis. The AI compares the description, check location with the CMU campus, and attempt to detect possible fraud pattern. The AI return the confidence score and listening, which is displayed to the administrator in both Thai and English. This helps administrator make faster and more informed decisions when approving or rejecting claim. We choose to use AI instead of machine learning for several reasons. Machine learning requires large training dataset and typically falls on classification tasks. It also lacks store listening capability and struggle with unusual or new item description. AI model can handle this situation better because they use contextual listening and can understand how human naturally decide item. We use Claude 3.5 Haiku as an AI model for our system. This model was chosen because it provides a good balance between performance, reasonability, and cost efficiency. Since our project operates with limited hosting and AI budget, Claude Haiku is a practical option because it is faster, cheaper compared to the larger model. It also performs well in multilingual environment, which is important because our system supports both Thai and English. Additionally, it provides clear explanation, which help administrators understand why a claim is recommended for approval or rejection. Now, I will explain the workflow for the user. First, the user logging in to the system to the welcome page. After logging in, they are taken to the dashboard, where they can find the list of the found items. User can search and filter items by category to find what they lost. If they find a possible match, they can view more detail and then submit the claim form, describing the item and explain why it belongs to them. User can track their own claim status in the My Claim page. If their claim is approved, they can receive a pickup location to the pickup center page. Next is the workflow administrator side. Admin first log into the admin system and can add file item into the inventory by entering details such as item name, description, and where is what file. These items are stored in the item inventory. When the user submits a claim, admin can view the claim detail in the verification section. Admin can generate AI analysis, review the result, and decide whatever to approve or reject the claim. If the claim is approved, the item moves to the pending pickup list, where staff can later confirm that item has been successfully collected.
Now I will demonstrate how the system works in practice. I'll walk you through the key features for both user and admin side. Let me begin by demonstrating the administrative interface, which serves as a command center for managing all lost and found operations at CMU. This is our landing page. Users can browse items anonymously, log in with CMU credentials to submit claims, or access admin portal. Let me show you the admin interface. This is the item tabs, where administrators register newly found items. The form is streamlined based on user feedback, using a single description field instead of multiple redundant inputs like brands and colors. Admins can upload photo, select category and subcategory, specify the location of CMU building codes, and set a storage location for retrieval. This is the verification tab, where submitted claims are reviewed. It integrates with Cloud API to provide a confidence score and analysis in both Thai and English. The AI evaluates factors such as description, accuracy, location, timing, and fraud patterns. Administrators can then quickly approve or reject claims, reducing manual workloads. The Item Inventory tab provides a comprehensive overview of all items currently in the system. You can filter by category, titles, descriptions, or locations. Each item displays key metadata. This centralized view allows the staff to quickly answer questions like, do we have any black laptops in inventory, or what items are awaiting pickup? This tab manages the collection of approved items. Once a claim is approved, it appears here for pickup. When the owner arrives and their identity is verified, the admin marks the item as collected, updating the status and recording the collection details. Now let me switch to the student-facing interface, which prioritizes simplicity and accessibility for the CMU community. This is the dashboard. It is the main browsing interface for students. To prevent fraud, it only displays basic information, such as category, location, and found date. Without detailed descriptions, students can search, filter by category, and browse recent items.
When students find an item they think is theirs, they can click this button and fill in the information.
The My Claims tab allows students to track all of their claim status and their claim request. Each claim shows its current status, pending, approved, rejected, or collected. This provides full visibility and improved trust by keeping users informed throughout the process. Finally, the Pickup Center tab displays approved items, approved claims, ready for physical collection. Once administrator approves a claim in the Verification tab, it appears here with its information. During development, we encountered several real-world challenges through user testing and development. I'll briefly highlight the key problems and how we address them. First, excessive input steps. The original registration form had too many redundant fields, making it slow around 3 to 4 minutes and confusing for staff. We simplified the form into a single description field. This reduced completion time to under 2 minutes, improved usability, and also enhanced AI analysis by using more natural input. Second, information exposure and fraud. Displaying full item descriptions on the dashboard allowed users to copy details and submit fake claims. We limited the dashboard to basic information only, category, location, and date. This creates a verification barrier and allows the AI to detect suspicious copy and paste behavior. Third, insecure OTP-based claims. The anonymous system introduced risks such as fake claims, OTP sharing, lack of accountability, and low user trust. We replaced it with CMU Entra ID authentication. This ensures all users are verified, eliminates anonymous abuse, and improves trust. Fourth, resistance to adoption. Some departments were hesitant due to workflow changes and preference for informal methods like Facebook. We introduced short testing sessions instead of full deployment. This reduced resistance and helped us gather practical feedback for improvement. Finally, system validation. We tested AI accuracy using both legitimate and fraudulent claim scenarios. The AI correctly assigned high confidence to genuine claims and low confidence to suspicious ones. We also performed security testing based on OWASP 2025 standards. and collected user feedback to continuously improve usability.
As for user feedback collection, we conducted short hands-on testing sessions where each participant used the system for a few minutes. After testing, feedback was collected using Google Forms. In total, we had 23 users, including CMU students, staff, and potential administrators. For task completion, from the results, 16 users were able to complete all tasks without any difficulty. However, 7 users reported experiencing minor difficulty during the testing process. In terms of time, more users completed the task quite quickly. 10 users took less than 2 minutes, 9 users took around 2 to 3 minutes, and 4 users took between 3 to 5 minutes. For usability, 12 users strongly agree that the system is easy to use. 9 users agree, while only 3 users felt neutral about it. When asked whether they would use the system if deployed at CMU, 12 people strongly agree, 7 agree, and 4 were neutral. Regarding system speed, 14 users agree that the system performs quickly and efficiently. However, 9 users feel that the performance could be improved. For bilingual support, 13 users were highly satisfied and 9 were satisfied, with only 2 users being neutral. For the claim submission process, 10 users were highly satisfied, 10 were satisfied, and 3 users were neutral. Looking at the overall system design, 8 people were highly satisfied and 13 people were satisfied, while only 2 users were neutral or less. Our team divided responsibilities into 3 main areas. Jakapan focused on UI/UX design, front-end development, and requirement analysis to ensure the system is user-friendly. Thanat handled back-end development, database design, and AI integration, including the claim verification system. Satikor managed testing, project coordination, and prompt engineering to ensure system reliability and accuracy. In conclusion, we successfully developed a centralized loss and found system. We implemented AI-based fraud detection to assist in claim verification. The system helps reduce administrative workload and was designed while considering real-world constraints. Thank you for listening.